Hi class. So today, good news is that as long as we're okay with what we did yesterday, we're not adding a ton of new information. The problem is just going to get a little bit longer today. So just take a deep breath right now and know that just because it's going to look longer, it isn't any more challenging. So today, one of the pieces that we're looking at is what it's like when we have a binomial and we're multiplying that times a trinomial. Okay, so what happens if we have something like x plus 2, right? That's our binomial because it's two terms. And we want to multiply that times 3x squared plus 4x minus 7, right? That one's our trinomial. A trinomial, right? That prefix tri means 3. So a binomial times a trinomial. And really, we're going to do the exact same thing that we did yesterday. Now, you could distribute in either order, but my students tend to prefer to make sure that they have the binomial in front. So if you ever see this written with the binomial over here at the end, that x plus 2 second, I would rewrite it and pull that binomial up in front because it just makes less pieces to keep track of. That's usually what my students prefer. Okay, and then we're going to do just like what we did yesterday. We are going to take the first piece of this binomial. So maybe we're just going to focus on the x, and we're going to ignore that second term of 2, and we're going to start distributing that x to every piece of the trinomial. Remembering that when we multiply with exponents, we add. So this really has an exponent of 1 on it, right? We just don't see it. So x times 3x squared will give us a 3x to the third. And then we're going to distribute to the next piece. X times 4x is going to give us a 4x squared, right? This x also has a 1 on it, so 1 plus 1 gives us the 2. Then we're going to distribute to the third piece. Okay, this one's a negative 7, so we're going to take x times negative 7, which will give us a negative 7x. Now, once we've distributed that first piece all the way through, we're just going to switch and then look at the second term. All right, so my second term on this one is a positive 2. So now I'm going to start taking that positive 2 and distributing it all the way through. So I'm going to take a positive 2 times a 3x squared. So 2 times 3 gives me a 6. That x squared is just coming along. We could write that 6x squared anywhere, but if we write it underneath the 4x squared, then we've made it so that we have like terms, right? These are both x squareds, and they're stacked on top of each other. Then we'll go to our next piece. 2 times 4x is going to give us an 8x. Again, we could write it anywhere, but writing it underneath the 7x gives us like terms lined up. And then a 2 times a negative 7 is a negative 14. Once we're there, we're good to go. And we can just add straight down. Okay, so now we're going back to our rules of adding and subtracting with polynomials. We're adding 3x to the third. A 4x squared and a 6x squared gives us a positive 10, and the label stays the same, x squared. Negative 7 plus 8 gives us a positive 1x. And then we'll just bring down the negative 14. So again, exactly like what we were looking at yesterday, we're just adding that extra piece to distribute to when we go through. Okay, so that's one piece that we're adding today. The other piece that we're adding is the last property that we haven't talked about with polynomials, and that's dividing with polynomials. Okay, and dividing by polynomials, remember we said anytime that we divide with exponents, we are going to subtract. So we're still keeping that property. And in fact, we're really just doing what we've done before, just a bunch of little pieces of it. The biggest thing with dividing with polynomials is just remembering that we have division signs that look different. So option 1, let's say we have something like 24x to the 5th plus 30x to the 3rd, and we're going to divide this all by 2x squared. When we are dividing with polynomials, all we are really going to do is take the denominator, which is the bottom of the fraction. Okay, so we're going to take the denominator and we want to write it under each term in the numerator. So underneath each piece in the top. So this gets a 2x squared and this gets a 2x squared. And then we're just going to treat this as if it's two separate problems. So we're going to focus on this first one right here. And we're going to divide with the rules we've already talked about. So 24 divided by 2 gives us 12. And then we subtract the exponents. 5 minus 2 gives us 3. Then we're going to look at the second one. So now we're going to look here. Okay, 30 divided by 2 is 15. And we're going to subtract the exponents. 3 minus 2 is 1. So you could put an x to the first, but you don't have to have that exponent of 1. And then that's just our answer. 12x to the 3rd plus 15x. Now, just like with any division, the numbers don't always have to be super perfect. So let's say we have something like 30x to the 7th y squared minus 18 xy to the 3rd. We're going to divide this by 2x squared y. So I'm writing a different type of division sign, but we are going to treat it exactly the same. So we're going to take each one of these pieces and divide it individually. Okay, so I'm going to start by looking at this first term. And I'm going to start using my division rules. So 30 divided by 2 is 15. Subtract for my x's. So 7 minus 2 is 5. And 2 minus 1 is 1. Okay, you could write that exponent of 1, but you don't have to. And we're going to go to our next one here. Okay, negative 18 divided by 2 gives us a negative 9. Now, when we subtract our exponents, 1 minus 2 gives us a negative 1, right? And when it's negative, it has to go on the denominator. And then we have 3 minus 1, which is 2. That's positive, so that one goes on the top. And again, this will just be our answer. There's one more way we can see division, so let's look at one more. Okay, and that's with our sort of division sign we saw way back when. But again, the idea is the same. We're still going to divide each of these individually by the 6x to the 5th. So 24 divided by 6 gives us 4. 6 minus 5 gives us x to the 1st. Now, next term, 10 divided by 6, we can't divide that evenly, but we can reduce it. So if we put in our calculator 10 divided by 6, we'll get a decimal. We don't really want to include decimals with fractions, so we're going to turn it into a fraction. Okay, and it's going to reduce it and tell us 5/3. We'll subtract exponents. 3 minus 5 is negative 2. It's a negative exponent, so it goes on the bottom. Last term, 12 divided by 6 is 2. 1 minus 5 is -4. And when it's negative, it goes on the denominator. And then this would just be our final answer.